Dad, where are you going?
Alex, I'll be gone for a long time. We're going to Peru.
But when will you be back?
I'll be back soon. I love you, buddy.
Hello?
Alex, I'm sorry to say this, but your dad was killed by a tiger in Peru. Here's his hat.
What's this old stuff? Dad's old notebooks?
I got your call. After all these years, you still have his hat.
He's my hero. I'll do everything I can to find that treasure.
Here are the coordinates to the location in Peru. You have to understand that this is a very dangerous undertaking.
I'll do anything to find that treasure.
Oh my god. I made it! Jack the Jack!
Where are we?
Where are we?
I wonder where we are.
We could use how fast the plane's falling to find out where we are. All right, so to find the speed at which the plane was falling when we crashed, so we made this model between the radar, our plane, and the ground. So we captured the distance being 7 miles between the radar and the plane, and 5 miles between the plane and the ground. We also clocked the speed between the radar and the plane at 315 miles per hour, and the horizontal speed of the plane at 550 miles per hour. So first of all, we need to make an equation to relate these. So we're going to use Pythagorean theorem. So this is our equation. And then first of all, we need to take the derivative. So we just use power rule, 2x, and we need to differentiate each of these implicitly. So we use chain rule and multiply by dx over dt. After that, plus 2y dy over dt equals 2d dd over dt. And then we can divide by 2 on both sides. So just cancel out all these 2's. And then first of all, next up we need to find our x, and we can just use Pythagorean theorem to do that. So you do 7 squared minus 5 squared equals, then we get, so our x distance is 24, is root 24. So we can write that down. And then from here on, we're pretty much just plugging in numbers that we already have, our distances and our rates of change. So our x is root 24 times our horizontal speed, which is 550 miles per hour, plus our y distance, which is 5 miles, times our dy dt, which we are trying to solve for to find the speed at our plane was falling. Then our distance between the radar and the plane is 7 miles, times the 315 miles per hour at which the distance between them was changing. Then from here, we're pretty much just solving for dy dt. Just gonna do that pretty quick. And then we got our speed, our dy dt, to be, dy dt equal to negative 97.89 miles per hour, which gives us the rate at which the plane was falling vertically to the ground at the point which we measured these distances. Based on the speed we fall to the ground, we must be in Peru.
Obviously. The coordinates told us to be in this exact spot. I wonder where the treasure is.
They must be nearby.
Here it is.
Whoa! Is that what I think it is? It says, "We the people."
That means the next clue is on the Constitution.
We should have to steal it then. You're gonna enter the National Archives Museum and you're gonna go down this long hall. And on the right, there's gonna be a locked door. And then when you get to it, I'll give you the code.
Alright, I'm here, Alistair. But what's the code?
So the code to enter the room is given by the volume of the room. So we need to calculate the volume of the room, and can be found using our blueprint which we made. So it is constrained from 1 meter to 15 meters, given by y equals the natural log of x plus 1, and that is all rotated around x equals 15. To find this, we can use shell method. So we need to start out with 2 pi times the integral from our constraints are 1 to 15, so our bounds on the integral are 1 to 15. And then we're multiplying by the height of the rectangles, which is given by our equation, the natural log of x plus 1. And then after that, we need to multiply by the distance from the axis of origin to the axis we're rotating around, and that is given by 15 minus x. And then we have to integrate that using our calculator. Then our volume is 1,560. So our combination to the room is 1560.
Alright, you're the man, Alistair. Alright, Alistair, I made it to the Constitution room. But how do I steal it? Alright, Alistair. We need a coordinate. Here's one, but there's a missing value. Maybe you have to find the radius of convergence. So the first thing that we do is we use the ratio test. This can be the limit as n approaches infinity of 5 to the n multiplied by n plus 1 over x to the n multiplied by x to the n plus 1 over 5n plus 1 multiplied by n plus 2. After you multiply these two things out, what you're going to get is x to the times n plus 1 over 5n plus 2, the limit. Alright, you can then break this up, so it'll equal limit as n approaches infinity of n plus 1 over n plus times the limit n approaches infinity 1 over 5 multiplied by x. You can then take this and plug it into this and find that the radius of convergence is 5. So we negative 5.
You realize you just wrote math on the back of the Constitution.
The coordinates in the back of the Constitution brought us to this mountain in Spain.
We have to go to the top to find whatever it is.
But where's the box?
Oh my god, is that it?
Oh my gosh. Of course, the Euler's method. But what are the starting coordinates? Of course, the coordinates that we started out with. Negative 75 and negative 9. Alright, so to do Euler's method, I have the x and the y coordinate. Change in x to y over d of x. And change in y. The change in x is going to be 25. So what we're going to do is we're going to plug in our two coordinates into the dy over d of x to find this value, which is going to be 1 over 5 times negative 75 plus or minus 9. 1 over 5 times negative 75 equals negative 15 minus 9, which is going to equal negative 25. It's going to be the dy over d of x. You multiply these two things together. 25 times negative 25 equals negative 625. Alright, and then we'll find our new coordinates. So it's going to be negative 50 over, okay. Our next spot is negative 634. Alright, and then we'll do it again. The change in x is also 25. dy over d of x is going to be, we'll plug in 50 for x, negative 50 minus 634, which is going to equal negative 10 minus 634, negative 644. You multiply these two things out, right? And then And then the change in x multiplied by dy over d of x is going to equal negative 16,100. Alright, and then we'll find the new coordinates, which is negative 25 over, and then negative 16,734. Change 25. And then let's plug these two values in. So it's going to be 1 over 5 for negative, or multiplied by negative 25 plus or minus the 16,734. Negative 5 minus 16,734 equals negative 16,739. Alright. This is going to be a new value right here. And then we multiply these two values. This is going to equal negative 418,350. And the box asks for the approximation of f of 0, which is going to equal 0 and then negative 435,084. Alright, it looks like we have to plug the numbers in. It opened. There's nothing inside.
Well done, partner. I was testing you this whole time. You're the only person left in the world that could get this from me. Now that we're here, I guess I'll just have to blame it on Tiger like I did to your dad. You'll never get my treasure.
You're dead to me. How could you?
Whoa! Ah!
I did it, Father. All for you.